speakers at the end to answer. So without further ado, let me introduce our esteemed speakers for today. So first of all, I would like to introduce Mr. Angertdev Singh, who works in Citi as a data scientist, specifically in the area of financial crimes. Hello, Mr. Angertdev. Next, we have Mr. Tian, who works in Naluri as a data scientist, specifically in the area of digital therapeutics. Last but certainly not least, we have Mr. Manbir Singh, who works at a financial institution as an IT auditor with particular focus on information security. So welcome all our speakers. As mentioned earlier, the objective of this talk is to provide our viewers with a deeper insight and understanding into the area of data science and cybersecurity. So my first question to all the speakers, and we will start with Anger. What is data science? And can you also tell us a little bit about your educational journey after SPM that have made you decide to choose data science as a career choice?
Okay, hi Zukrina, thank you for the introduction. So basically data science is a family of roles that use data to solve certain problems. And although the techniques to solve these problems don't really matter, there tend to be a certain set of tools that we do use most of the time to solve these problems. So essentially data science is using statistical methods and algorithms to find information in large quantities of data and to turn this information into predictions or actions that we can do moving forward. Some of the places that you might see data science being applied, for example, when you open up Lazada to buy something, and then when you log in again the next time, it curates your recommendations based on what it thinks that you will want to buy in the future. And these have to be relatively intelligent. Like, for example, if you buy some orange juice, maybe it should offer you cups, for example. And then also there are uses in other cases as well. So for example, Google Translate, when you're trying to translate a document from one language to another language, it's infeasible to manually write down rules of how to translate every language into every other language, right? So using data science techniques, we can build or train these things called models, which are essentially algorithms. And these algorithms learn how to convert one language into another language. And there are plenty of other use cases, which I'm sure Tian also will talk about later. But yeah, now I want to just touch on some of the roles that are available within data science, right? And some of the roles that you will often hear are things like business intelligence, data analyst, data scientist, data engineer, and machine learning engineer. And there's overlap between these roles, but in general, how you can think about them is that business intelligence and data analysts, you will tend to look at data in the past, and you'll be building reports, finding insights, and looking at trends. And if you think about data scientist to machine learning engineer, then there's more of a prediction component. So how can I train algorithms that can then make predictions for the future? And then data engineer is highly important and I think very undervalued. They are basically the ones who build the pipelines and ensure that those models and reports don't break down over time. And it's a role that I don't see talked about enough, but it's something I want to encourage everyone to look into. Yeah, so that is basically what data science is. And now just a brief history about my educational journey. I did SPM, in which I did the basic science subjects, basically maths. And then I did A-levels, where I did maths, chemistry, physics for the maths. And then after that, I did a master's in chemical engineering, which is not a data science related subject really. But I'm trying to really emphasize that you don't have to come from a computer science or maths background to go into data science. Sometimes having some domain knowledge in a different domain can be very helpful because you have another set of tools that you can use to apply to these problems. Yeah, so that's about it.
Thank you. Okay, Mr. Tian, is your pathway a little bit different than Mr. Anger? Or is it fairly similar? And what about his comment on data sciences? Do you agree with his statement or is there more to it?
Thanks, Zukrina. We agree on many things. And actually what's so fascinating about this field is that 10 years ago, you would never have heard the word data science before. And my definition is it's actually just modern day statistics. So if you've been a statistician all your life, you're also a data scientist in that sense, just to make it a bit more simplified. And what I find very interesting in this field is that there are a lot, if I just look at my classmates, because I did a master's in data science in University of Essex just 2 years ago, a lot of people that come into this field come from a variety of diversity of industries, right? Psychology students take statistics like a fish to water because they have to have the scientific rigor to be able to justify and prove a hypothesis in an area of humanities that is so subjective. People who are in software engineering pick up the coding part of it very well. And I still remember some people ask, is it very important for me to code to be a data scientist? Well, no. If you would like to build your own graph by paper and make your ANOVA models using a ruler with a graph, then yeah, it's perfectly fine, but it's actually meant to be helping you. Economists, for example, if they're very strong with econometrics, they will take this to a fish to water as well. In fact, some of the areas in neural networks, right? A psychologist or someone who's trained in neuroscience can find areas and parallels that's very familiar to it, so they can understand at least the source material of how that discipline came to be. It's not a direct translation, but there is a foundation over there. And if anything you can take out from this is that nothing new is ever, everything new is something old in a different name, as I would say it, right? So if you're strong, if you're from mechanical engineering, if you're from chemical engineering, or if you're from humanities, or if you're a linguist, and by the way, linguists are very good at natural language processing because that's computational linguistics. You can find an entry into data science because it's a big field, very early field, and it's up for us to define it. So I hope that answers the question.
Thank you, Mr. Tian. Can you also tell us about your educational journey after SPM? So,
in brief, by the way, my name is Tian. I'm 35 years old, have been married, based in Kuala Lumpur. After SPM, I don't know what to do. And I think everyone relates to that a little bit. I got an expectation from my mother, though she wants me to be in medicine. So because I don't know what to do, I decided to buy myself a little bit of time and do my SDPM in 5 subjects, like physics, chemistry, biology. Yes, I did that. And I still don't know what to do. To appease my mom, I actually qualified for 3 medical offers and I didn't take any of them, to her chagrin, that son. I actually went for a computer engineering course in National University of Singapore, but I dropped out 1.5 years later due to very bad grades. So that was my first disappointment. I finished my bachelor's in computing and software engineering in APIT, now known as APU. So I do know our COO, got first class honors, and then that embarked me on a 9-year career in IT, in banking and oil and gas. But I've only wrote code for 2 years of that 9-year career. But I picked up project management, business analysis, testing, everything else. And you'll later come to know that economics, personal agendas, and all these things have an influence about how your system will actually turn out to be, right? These are some of the things that we don't necessarily teach about in school. It's not just a technicality. My first exposure to data science is when I took a Coursera course, again, funded by MBAC, something that you can upskill yourself at. And I find my love of it because I think it's very relevant in this current age. And I enjoy doing the research. And so I thought, okay, it's time to make a career transition. I got the Chivning Scholarship, and that afforded me the ability to go study a master's in the UK, because in data science, there's no one governing body and one golden standard that this is your qualification. So I thought I'll use the academic route. And today I work for a startup in the area of digital therapeutics. And the reason why I'm very proud or very satisfied with the work that I do is because I know that the work that I do have a certain impact for a certain purpose. We're a company that helps to address mental health and chronic disease management. I mean, what if you have access to a dietitian, fitness coach, and all that, and make that accessible to everyone because you don't have to see them face to face, you don't have to pay for the consultation, and you can be from everywhere. I find that to be very compelling. And so something for everyone to think about. If you're gonna go to work 8 hours a day, 5 times a week, you're gonna do it playing a role in solving a big problem. So that's for me.
Thank you, Tian, thank you so much for that insight. So we know that data science is a very holistic field to go in, right? So the next person that I would like to ask, Manbir, your specialty is a bit different, right? Which is in cyber science. Can you possibly tell us what the difference is between cyber security and data science? And can you also tell us a little bit about your educational journey after SPM that made you pursue IT degree? And how did you venture into such field?
Yeah, hello everyone. Yeah, so I think there are three parts to your question. On the first part, cybersecurity is different compared to data science because data science, the main objective is to convert structured or unstructured data into actionable insights. Whereas a cybersecurity main focus or responsibility is to protect IT assets in an organization. What I mean by assets would be application servers, database servers, network devices, endpoints, PCs, and so on. So these are all considered to be assets. So cybersecurity main responsibility is to protect these IT assets from external cyber threats, from external state-sponsored attackers, and also from internal cyber threats. So that's the main difference between cybersecurity and also data science. To answer your second part, the main key motivation for me to pursue my degree in IT back then at APU was because IT has a huge demand in the market, regardless of the industry. It can be a manufacturing industry, it can be a banking industry. So if you look at any entity, any organization, you would find an IT department because that would show the dependency of the business processes on IT systems. And also now we have a lot of emerging technologies, cloud computing, AI, and robotic process or automations, RPA, and so on, right? So that was the main key motivation for me to pursue an IT degree. So I pursued an IT degree at APU. My focus was in business information systems. So that means I was actually targeting for career options like being a business analyst or a functional consultant. So that actually would answer your third part of the question, how I actually ventured into cybersecurity, because what I majored at APU was slightly different to what I'm currently doing or what I'm currently focusing in, which is cybersecurity, to test the effectiveness of cybersecurity controls. So I was lucky enough to start my career at Big Four. So I started as an external IT auditor, where my main focus was to assist the financial auditors, because a lot of financial reports like general ledger and so on were being reported from the financial application. So as an external IT auditor, my main role was to test the effectiveness of the application controls. Then following my first job, I joined a fintech company, and that fintech company, that was my turning point when I joined the next company, right? Because I joined as an IT security and compliance consultant. So I learned the fundamentals of cybersecurity, like doing vulnerability assessment, penetration testing. So since I didn't major in that background, so I did my own research, and I was lucky enough to have a very kind superior. He taught me, he did knowledge transfer to me. He told me, Manbir, look, you download this tool. This is how you can do exploitation. This is how you can identify the vulnerabilities of the network vulnerabilities, of the web application vulnerabilities. So he taught me, and then I guided and I adapted well. So, but then my goal was to join a financial institute, because I knew that the banks are very heavily regulated. So I wanted to get a peak of it, like, what's being in a very highly regulated industry. So that was the reason that actually motivated me to join a financial institute. So currently I'm working at a local banking group as an IT auditor, where my main focus is to test the cybersecurity controls. So when I say cybersecurity controls, would be like generally a company would have security operations center, where they detect and they respond to cyber incidents. You would have a data leakage protection capabilities and so on. So currently I am actually testing the effectiveness of this cybersecurity controls.
Thank you, Manbir, for that thorough insight on cybersecurity and IT auditor. Okay. Moving on to the next question to Mr. Anger. Okay, so in terms of going to university, if I wanted to go to university and possibly pursuing a career in this field, what are the necessary academic requirements would I need to enter?
Okay, yeah, I think Tian has already touched on this a bit, so I'll try not to repeat myself. But basically, math skills are necessary for sure, but you don't have to be, just maths obsessed. And I think the other thing that people usually think is that maths is something you either are born to do or something that you're not able to do. And I really want to stress that it's something that you can really learn to do. And the maths component to data science is a supporting component. So as long as you have a reason that makes you want to go through the mathematical portion of it, I think it's something that is very doable. Some of the non-negotiable things, though, I think are things like the willingness to continue learning, because it's a field where once you've done your degree, for example, or your master's course, you can't stop learning because the field is constantly changing. The tools that are available are also constantly improving. So you will need to constantly be learning to be able to stay on top of all these developments. So in terms of specific courses that I would recommend, I have no real specific courses because one of the best data scientists I worked with was actually qualified as a lawyer and practiced as a lawyer for a while. So, you're not restricted to the fields. But for example, if you feel like you really want to work with natural language, then like Tian said, linguistics is a good option. Or also something like computer science, because that will give you a good, strong foundation, because a lot of these like cutting edge tools to work with a language or to work with vision, so things like self-driving cars, if those sorts of applications interest you, then maybe go into something like computer science. And then you should be good at thinking in terms of processes and so on and so forth. But otherwise, if you want to be a data scientist in other fields, then maybe you can think about a degree that is more related to that domain. So for example, if you want to be a data scientist in finance or banking, maybe actuarial science is which is basically the old-fashioned name for data science anyway. So actuarial science is a good course, econometrics, economics, or finance, or don't hold your back. Almost any degree is fine. I think it's more the attitudes that are important in this case.
Okay, thank you. Thank you for that insight. Okay, next we move on to Tian. So as a data scientist, can you briefly tell us the general job scope that you do, or maybe our fresh graduate might, learn to do or might expect?
Yeah, very good question. I would say in general, if you think of yourself as a statistician or a data scientist, in general, what you try to do is that you have a lot of data and you are supposed to graduate all that data into a certain kind of understanding. And when you have that understanding, that's where you can build capability, right? That's a very good rule of thumb to go by. So think of yourself as like a detective, right? You have to explore the problem space. You have to develop an understanding of what's going on, because there can be so many possibilities and there's a lot of noise and the evidence can be contaminated, right? You have to come up with some hypothesis and then you have to test it. Now, if you see from all the data over there and you're very convinced yourself, because the first thing you have to do is to convince yourself that there is an opportunity and which you're supposed to do something, then you build that capability. And sometimes you may have to deploy it yourself. That's also part of being a data scientist. We're not just armchair mathematicians here. So that's in general what you do. But what is interesting about what your job scope is dependent on your industry and your company. So I'll give you one example. There is an algorithm known as anomaly detection. So all it does is, from 4 different types of pictures, this one is the odd one out. That's my simplistic way of explaining it. Okay. If you were to go to oil and gas, you can take that algorithm and you can apply it to predictive maintenance. You know and predict ahead of time which compressor is going to break down, because if it breaks down, it will mean they have to defer the operations, and then you lose millions in opportunity costs for all the oil that you did not produce. You take that same algorithm and go into finance. You can do fraud detection, where you can look at someone's credit ratings and information and discern whether this person is able to pay you back or credit worthy. Same algorithm, bring it to security. Yes, you can go into those areas, and now you can find out which network behavior is the most suspicious. That doesn't look like a natural traffic kind of pattern, right? And if you go to manufacturing, you can use the same thing to find out defects in products or in the process, which can help produce higher throughput. And in my space in digital therapeutics, I mean, I'm free to defend whatever it is, because I can see whether a person is what we call at risk emotionally, whether they are on the suicidal spectrum or depression spectrum, whether they need attention. That will help us with our prioritization. Or you can even look at like blood samples and say, okay, these few are not healthy. You need to go check those things out, right? So one solution, different problem context, and it translates across beautifully. And that's the real genius of being a data scientist. You see one problem context, you can translate from what you already know, and then you see, well, one solution can actually solve many different things.
That's very interesting to think about. Okay, my next question, Manbir. So how does the job scope of a data scientist differ from a cybersecurity? Can you briefly tell us the general job scope of a cyber IT auditor that focuses on the field of cybersecurity?
Yeah, sure. So I think I would like to comment about the financial industry because currently I'm working in that environment, right? So the financial institutes are being regulated by Bank Negara. So I would really recommend students and also fresh graduates to just do a quick search on Google, RMIT, Risk Management in Technology, BNM policy document. It's publicly available. Go and read up this policy document, understand the requirements and objectives, right? Because this is actually the key driver of how to govern the IT elements and environment of a financial institute. So in this document, you would realize that a CISO, right? A CISO is a Chief Information Security Officer, is responsible of the technology risk management functions. And then you have to also implement proper data leakage protection capabilities. You have to have tools to detect and respond to cyber threats in real time. You need to have proper mechanism, tools, and proper processes built into the network, right? So, and also there's a requirement where you need to have a very dedicated and professionally certified IT auditors to govern the first line of defense and also the second line of defense. So the first line of defense would be those individuals who are responsible in implementing the security controls. The second line of defense, they would do an oversight function to make sure that whatever has been implemented have been assessed with the right level of assurance. And then the IT auditors, we sit at the third line of defense. So we are independent. Even though we are independent from the business functions, we are not independent from the company because we need to be like these strategic and trusted advisors to the first line of defense and also the second line of defense. So my general scope would actually to understand the processes, the people, what kind of tools are being implemented, and to ensure that the technology risk management framework have been properly implemented. So generally, when I've understood the universe and the environment, right, when I do my auditing, right, it's actually broken into three main phases. You have planning stage, you have fieldwork, and you have reporting. So in planning stage is where you identify the high key risk areas where you want to take a deep dive into, and obviously we need to cross-check with regulatory guidelines. Because we're being regulated by Bank Negara, we're being regulated by PayNet, and also then we scope down. Okay, so these are the subsidiaries which we would like to get the necessary assurance on the effectiveness of the security controls, right? So that's under the planning stage. Then we go to the fieldwork. Fieldwork is where we do the necessary walkthroughs with the control owners, with the process owners, get the necessary information, the logs, the screenshots, the configurations, so on, so that to support our audit objectives. So as an auditor, I think an auditor and a lawyer they're very similar because we rely on facts, evidences, you know, and we just can't just throw any facts into the air. It has to be concrete, right? So that's when even when we go for exit meetings, you know, we have to always justify and defend ourselves with proper solid evidences. So exit meeting is another scenario, but then it goes to reporting, right? So reporting is where you have to convert whatever you have observed, whatever you have understood, right, during a fieldwork, using the right jargons, phrases, and so on. Because at the end of the day, the report will be read by the board members, will be read by the senior management officials. So I think reporting also is another key deliverable, and also is part of the job scope of being an IT auditor. Yeah.
Thank you, Manbir. Okay, so from that discussion, you can clearly see if you do want to pursue an area in this field, then these are some things that you guys have to endeavor and go through. Okay, next question, Angert. Let's go on to more of the working environment, the working situation. So how would you describe the working environment as a data scientist? Is it competitive? Is it tough?
Sure, yeah. So I think in my experience, just like almost any other job, it can vary quite a lot based on the context of the work that you're doing and also the industry that your company is in, right? So for example, let me just talk about firstly in terms of the different data science type of engagements that you could have. So for example, during my experience as a data scientist in a consulting team, there's a lot of client facing, so you have to be really good at effective communication. There's a lot of collaboration with people who are not technical as well. So you're running through these things with people who have, maybe subject matter expertise. Let's say if you are delivering some sort of learning management tool, so you will have people who are experts in HR, for example. And then your component is predicting what sort of modules people should learn to improve X, Y, Z skill. And then you will have project managers as well, and clients who maybe have 5,000 employees that they want this tool to serve. And you have to be able to juggle all these different roles. So, a lot of soft skills required in this case. And then the other type of role that I've been in is, for example, a product team. So in this case, you could be maybe you work at Apple and you are in the App Store. So then in product teams, there's a lot of focus on things like fast iteration cycles, because there are app releases every maybe 2 weeks, and you are trying to make constant improvements to your product within that duration. So that'll be a good fit for you if you like to constantly see to have a good feedback cycle on between your work and the outcomes of your work. Finally, there's also definitely a role for people who like to do long-term projects. So I've been on a project where I've had 6 months with an unclear objective, and I have to find out what is exactly the problem that we're trying to solve, what data do we have access to that we want to solve. And this one, there's a lot of independent work, but then you have to be able to communicate your results to stakeholders and convince them that this is a problem worth spending resources to solve, essentially. So you definitely cannot escape the communication aspect of the role. And finally, if none of these, if all of these sound interesting to you and you want a bit of everything, and then you can also be a generalist data scientist. And in which case, a good fit for you might be things like smaller companies or startups, because then you will be doing things like, data acquisition, so finding data, training models, deploying these things into real-time production, checking how they do, monitoring their performance over time. So the environment can vary based on which one of these you see as a good fit for you.
Okay, my next question, I think I would want to contrast it with Manbir. How would you describe the working environment as an IT auditor as opposed to what Angertdev has described?
Yeah, so the working environment is sometimes we have a fixed, so we have an audit roadmap, right? So we have fixed audit projects, and sometimes we have also ad hoc audit projects, because we have requests from regulators and so on. So that's how sometimes we need to align our resources accordingly to match the expectations of internal and also external stakeholders. And the working environment, we have to interact with various departments, not only IT, it can be procurement, on third-party risk management, it can be, or with the transaction banking department, and also we have to interact with various stakeholders at different management levels. So that's the working environment when you are an IT auditor. And and I think I just would like to share also, if let's say within the internal audit department now, we have a very positive environment also, where we do a lot of knowledge transfer sessions, and then sometimes we have to collaborate with also non-IT auditors like operational auditors, or even because we will also have a dedicated team doing data analytics in the audit division as well. So sometimes we have to collaborate and also partner with them depending on the scope and objectives.
All right, so moving on a bit slightly. So this question is to Tian. What do you think are some of the challenges that you face working in this field?
Yeah, it's very challenging, and not all challenges are fun. So here are some of the challenges I can think of, the top 3. One is this hype versus reality, all right? Because many people say very few understand and very little actually do. So a lot of people have been talking about data, AI, and they twist their own meaning into it, and there's a lot of misconception around it. So when you establish a kind of hype and reality, I mean, the hype is that these things would be will be sanctioned and they will overcome the human race. They will say that we expect magic because the AI can be trained to do everything and we should trust it. That's not true, right? And you being in this field, you actually get to see for yourself how much of this are still myth, and in reality, what actually things can be achievable and feasible, and what are areas of research that are still ongoing. So when dealing with this hype and reality with your stakeholders or with the public for that matter, it's very important that you know how to educate, right? Use simple words to explain to people who are non-data scientists, non-engineers, what we're actually building for them, and to have very clear expectation about what will be delivered. It goes to say that just from the questions that I heard from what was said prior to Gurpradip earlier, right? What if there's a lot of ethical grounds around this, right? And what if the data is misused? Well, that's our job. So what I have in common with all these folks in this panel is that we don't trust, we verify, we learn, we make sure that someone explains what the machine does, because we can easily be lulled into complacency. And that's the reason why, for example, A-level results get predicted instead of actually getting scored. That's quite unfair, right? If you hear some of those incidents that happened before. And with regards to all the hype about, this will be the next big thing, well, we have been through more than 5 AI winters. And by winters, that's when the investment in AI has depleted and it's no longer an optimistic curve. So that's been going on since the 1950s, right? This is no different. But the clear thing is that with this kind of skill sets, it won't go anywhere. You will find these skill sets going into every other person's role, right? For you to be a more effective aviation engineer, you have to understand a little bit of data science. For you to be a good executive and a CEO of your organization, you cannot just go by the buzzwords. You actually have to learn it up for yourself. People worry that computers will get too smart and they will take over the world. The real problem is they have already taken over the world and they are not very smart. So that's the reality of what we're dealing with today. That's the first thing. Second thing is that as a data scientist, the skill of being able to define the right questions and to be able to validate whether the answers are good are more important than ever. Because if you have a black box and you can throw whatever you want at it, expecting what's going to come out is something that's not humanly possible for a human to do, then you have to define your questions very clearly. For example, people think that predictive analytics is the most important thing, right? Well, in the HR world, it doesn't matter if you can predict performance. What you want to know are the drivers' performance. So now prediction is no longer important to them, but knowing the root causes and the drivers for performance is. Let's say you get a reading from that AI thing that you built, right? How do you know it's actually true? Because it has bias in its own ways. And this is how I explain it to a lawyer. If the justice system is conducted through AI, and you want it to throw all the criminals into jail, the way to cheat that is to throw all of society into jail, then all your criminals in jail. Conversely, if you want now to optimize it, how many people in jail are actually guilty, then the way to cheat that is to throw all of them out of jail and only leave one. So understanding the complexities that is involved would show that you bear a very big responsibility when you ask a question, and you need to decide whether you're getting good answers. And finally, you need to be able to simplify the problem and explain this to non-technical people, because the depth of your understanding is really shown when you can speak other people's language. Just like in the case that I've shown just now, I had to explain to lawyers what AI is about, right? And that's a good test and a good exercise that you understand it yourself.
Thank you, Tian. Okay, I would also like to direct the same question to Manbir. So from a IT auditor's point of view, what are some of the challenges that you face in cybersecurity?
Yeah, so I think number one would be, because then I feel I'm overwhelmed with a lot of information, because one audit, I might have like 50 to 100 different types of documents. So as an IT auditor, I really have to analyze. I have to look what the policy is saying, what is the objective. So you have to go through, analyze, and then you have to cross check with various stakeholders to get the correct interpretation, right? So when you are being drowned with this sea of information, right, I think it's very important to take a step back and think, okay, what's my objective? What's the key risk area which I would like to address? Why am I asking this document, right? So it's very important to have that coherent mindset and organize your information in a very systematic way, right? So obviously, then you need to go back again. What is my audit scope and objective? Am I going out of scope or am I still within the scope? Because that's very important, right? So that's number one challenge, and then I do face. And another challenge is also report writing, because at the end of the day, the report is the key deliverable. So like my superiors would tell that at the end of the day, the final product is the report, right? And obviously the quality of the findings and so on. So, and that report is going to be read by the board members, is going to be read by senior management officials and so on. So you have to, number one, you have to think, how are you going to present your report? Is like telling a story, right? And you have to keep in mind that your readers might be from the technical background or not from a technical background. So which words you're supposed to use to convey the right message, right? So choosing the right words, the phrases, these are very crucial, right? And the second part is when you are highlighting any observations or any area of enhancements, right? We don't want to downplay them. So that's the reason when it comes to report writing, we really have to use the correct tone so that the right message is given, and then subsequently, the gravity or the situation importance is escalated to the auditees and also the officials, right? So that's the second part. And another challenge that sometimes I do face also is that sometimes when you present your audit observations to your auditees, we have to keep in mind that they are subject matter experts as well. So they have years of experience in managing security operations center. They have years of experience in managing vulnerability assessments and penetration testing. So they might have their own level of interpretation. You also have your own level of interpretation. So in order for you to actually put that into a report, firstly, you have to gain concurrence with them as well. You can't just simply, without hearing their side, what they have to say, you're just going to put it in report and publish it and send it to the respective recipients, right? So I think that's very crucial also to explain to them and gain concurrence so that everyone is on the same page, and then the overall audit program is a success. Yeah.
Thank you, Manbir, for that. Okay, the next question is to Angert. Okay, so as a data scientist, what do you think are some of the misconceptions that people make about data sciences?
Yeah, so I think one of the main misconceptions people have before going in is that they will be able to solve every problem with data science, for example. There are some things, I think, especially when we start out as data scientists, we can be guilty of, because it can do a lot. And the tools that you've been playing with, you see how well they perform on so many different problems that, you start thinking that maybe it can solve every problem. But the thing is, some problems are hard because there's something inherently difficult about them. And there are people with domain expertise who have studied these problems for a very long time. And it is really important for data scientists to keep people with domain expertise and subject matter experts within the data science production loop, for example. So one of the steps in data science, for example, if you're training an algorithm, is to decide what data goes into a model. And if you're a data scientist who has just entered a certain field, let's say you've entered into some sort of social welfare field, where you're trying to predict which school you should give extra funding to improve their outcomes. And then you use some features for your model to make predictions. Features are just characteristics, right? And one of the characteristics you use is, let's say, the postcode of the students. But if the people who have subject matter expertise would realize that postcode a lot of the times is just an indicator of how wealthy your family is. So it might not be a fair indicator to use something like that to predict people's school outcomes, for example. And there are many other scenarios in which these sorts of situations happen. So that's one misconception that people have. The second misconception that people have is that objectives are always very clear and obvious. Because in data science, one of the most typical problems that we have is something called a classification problem, right? So you get in a list of people, let's say, and you want to decide whether they're in category A or category B. And a lot of the times we don't have to think about what category A and category B even means. But actually probably 80% of the problems, you have to first define which categories are even possible for people to be categorized into, right? And, you know, if let's say you decide that people can only, you know, fall into category A and B, but actually there are category C, D, and E in real life. So when your model makes these predictions in the real world, it won't be so effective. And secondly, the other thing that is important is objectives that seem important when they're not the full picture, right? So for example, when you think about self-driving cars, the objective you might think is for a car to be able to travel safely most of the time. But really, that is a very simple problem. The real challenge of self-driving cars is the edge cases. How do you drive in heavy Malaysian rain, for example? That's a very, very hard problem. And so sometimes it's deceptive to identify what the actual problem that you need to solve is. Yeah, and finally, I think the final one is also another one that when you're starting out, sometimes you can fall into this trap, is that you've learned all these, you know, very interesting algorithms, very fancy things. You might have done some deep neural networks and all that. And you try to apply these super fancy techniques to problems that really a very simple technique could have done. So for example, you can draw something, a linear regression. So just a simple straight line can give you 95% of the results in 2 weeks, but you spend 3 months building a deep learning model, let's say. So that's the final misconception that, sorry, yeah, and just one more that I want to highlight again is that it's not just for people who love maths. I know I've said this 3 times now, but it's something that I hear all the time that, you know, I don't like maths or I find it difficult. Can I still go into data science? Yeah, that's a misconception people have. You definitely can still.
Thank you for that. Tian, I saw you nodding a lot and was thinking about the question. So do you have anything to add, or do you think it is spot on and you agree with everything?
Angert is very thorough. So you've done your profession well. I would just add one point, and that is when we study something, there's this curse of knowledge. And that's the thinking that we think we have to apply all of our knowledge to bear fruit for something, right? Simple is beautiful. And because if you're not simple, then the antithesis to that is perfection. And perfection means complication. And there's a lot of noise when there's a lot of complication. So defining the problem in its most simplest form is still something that's very difficult to teach, but it's something that is very learnable, right? And if the way you define the question can put you in a totally different direction, whether you be led astray in your research or whether you actually come up with a nice, elegant, and simple to use problem that is actually cost effective and everyone can do it. That's still a very key thing. In statistics, we have, well, in hypothesis testing, there's what we call type 1 and type 2 errors. Okay, get ready, this is some math. Type 1 error is you don't reject the null hypothesis when you should have. Type 2 error is you failed to reject the null hypothesis when you should. But this type 3 error, and this is where I'm gonna break it down a bit. That means you've already rejected the hypothesis, you proved your case, but you did it for the wrong problem, right? It goes back to asking the right questions, making sure that the problem that you're solving is the right one to solve, and whether you pick the right simple solution for it. It's too easy for us IT tech folks to go into solutioning mode immediately. You have to sit with the problem. I guarantee you, when I start a project, the problem statement changed 5 to 7 times. The executive suite have a different view about it. They don't agree yet, right? And that's good. You need a diverse perspective on it, but you have to get everyone to agree that this is the problem for you to solve before you start spending money and all your engineering and your time on it. There we go.
Thank you. Okay, so the discussion, I think, has been a very fruitful one. We got a lot of insight about cybersecurity and data science in general, and what that field of study encompasses and what you have to do. So I think our discussion time is up, so we'll move on to the Q&A session. So let's see the first question. Okay, the first question is currently in a full stack development bootcamp. After years of odd jobs and gaps in resume, how do I ensure myself getting employed stacked up against degree grads? So who would like to answer this question? Okay, Mr. Tian.
Okay, I'll take that one. You don't have to, okay, there are a few problems here, but I want you to recognize a few things, right? One, just because you don't fulfill everything that's in the requirement in a job vacancy, that's not your fault. It's less of a judgment of your skill. It could be a judgment about a fit to the company that was working on all these technologies. Some engineers could probably create something in R because they know how to do R, and then the rest of the team doesn't know how to support it, and that finds its way into the job vacancy, right? So there's a bit of an overinflation of all those kind of skills that is required, and we're not perfect. Truth be told, I still struggle with Python to this day. That's why your fundamentals on just knowing what you're doing is very important. Technical gaps are always there. We will learn them along the way, but make sure that whatever you learn, there's a purpose. There's a purpose for you to deliver something, and that makes it more meaningful because it's in my head. If you, one skill that you have to learn, as far as a hard skill is concerned, it's like a soft skill in disguise. It's actually prioritization on what to train yourself up in, right? In that sense, you can't go wrong if you have one programming language like Python, one for querying SQL, and one platform to deploy it. Like, just pick AWS or GCP. If you can't pick, it's a binomial question, flip a coin. And when it lands, you know whether or not you agree with it or you disagree with it. Don't spend too much time on it, right? So first, there's this problem over there, right? There's the expectation from the industry themselves. Two, there's nothing stopping you from showing your work and building a portfolio, right? And that tells more about your ability to get stuff done. That explains a lot of leadership and initiative on your part to go and fix the problem with little to no budget. Imagine the kind of person who hires you, knowing that you did that in 3 months with your own resources into the company. That speaks a lot more. So these are the two things that you have for yourself to go about competing with everybody else. But also, it's not competition. It's about coexistence and collaboration. This field is just too big, right? Later on, I guarantee you, I'll be talking to Angertdev, I'll be talking to Manbir, right? We'll be sharing information because it's just too big of a field. So you should be proud that this is a field that is growing so quickly. And the biggest pride to you is that if you mentor someone to later on become a competition for your own job, that says a lot about you in crafting, in guiding talent.
Zukrina, if I can just add, right, because I think one thing that Tian touched on is really important. So when you're coming from a non-traditional data science background, like I did, I think the most important thing is to be able to have some work that you've done that you can point to and explain thoroughly. You don't have to know everything, right? It's impossible for everyone to know everything. And I've conducted data science interviews as well. So for example, in the case of the lawyer turned data scientist, he had a project where he had sourced the data himself. He had evaluated the data. He knew the data, the properties of the data inside and out. He could explain his decisions regarding why he did certain things to the data and why he did it. He could explain what the outcome was and whether it was what he expected it to be like, and how people would interact with the tool that he built. So, I can know for sure that he understands the end-to-end of at least a certain subject. He might not be able to do everything, but he can do some things really well. And I think demonstrating that is the most important thing.
Thank you for that. Okay, the next question is, what is the document Manbir suggested to us to read on?
Yeah, so the document is called RMIT. You can just do a quick Google search, RMIT Bank Negara Malaysia. So this policy document is actually mandated for every single type of financial institute. Can be an insurance company, can be a banking institute, can be an Islamic bank. They are mandated to follow the requirements and also the key domains which have been stipulated in this document. So it's very, I think it'll be a very good head start if you can read, understand, And if, because the most of the requirements are very generic in this policy document, right? So if, let's say now you as a fresh graduate, you would like to join a banking institute as a junior staff, right? And if you can explain your interpretation, or how can you test certain of the requirements using, maybe based on your research which you have done, based on certain best practices of let's say encryption, right? You know which are the obsolete encryptions and so on. So if you can share some of your insights on how you can test these requirements and show the effectiveness, that would show that you're having a high level of passion and dedication in making cybersecurity or IT governance as your career objective.
Right. Okay. Next question is, can the speaker share some personal experience that they might have struggled with while working in their field? So some personal experience that you guys might have encountered that might provide some lessons to undergrads or people that want to pursue a field in cyber sciences?
Yeah, I'll go first, I think. So I think when to think of a challenge as relevant for when you just enter the field, right? You're probably coming off maybe some, if you're moving from a different industry, maybe a boot camp or some self-study, or maybe you took a course, or you have some sort of related experience, and you are coming into a role that is generally expected to have some technical knowledge. And you've spent the past 1 year, 2 years learning things to be competent at the technical aspect of your work. So then when you join a team, a data science team in a company, and you are expected to be able to communicate with people who are non-technical, that can be a bit of a challenge. So for me, for example, it was a challenge at the start to be able to turn or to explain why certain technical decisions should be made in a non-technical way, because you have to make sure that you don't trivialize the decision. So, people who are non-technical don't feel like it's something that's not important, and you can just change it based on what they feel it should be. But it also still needs to be convincing as well. So they should feel like it's a valid reason for you to be doing it the way that you are doing it. And when sometimes if you don't manage to convince people on the non-technical side, they might still let you do things, but you might not get buy-in. So then you don't get the results of your work are not benefited by many people, right? But if you have buy-in from everyone, they can't wait for you to finish the work that you've done and to use it and give you feedback for you to improve it. And then, it compounds itself. So then you get more resources for the next project that you want to work on. So that ability to translate technical information into non-technical information is a challenge you will most probably face, but really try and overcome that.
I have one very similar as well, actually one I learned from just recently. It's because we're also curious people. We generally have a lot of ideas. And then the moment I come into my company, we start branching off into so many different things. And I have a solution take off from my pocket from every one of them. But it means nothing if it's not, one, delivered, two, used. And so the lesson that I have to learn from myself, and this came from my performance review, so you're also benefiting from it. It's better to start off with like the simplest version of it. If you're going to do a recommendation system that recommends all the modules and all of the tracking tools and all the coaches you have to go talk to, okay, that's probably bar 13. What is bar 1? Bar 1 could be, I generate a recommendation on my computer manually on Jupyter Notebook, and I managed to get it to show as a dashboard in our company internal platform. That's bar 0. It has to be a meaningful piece of work where the value is delivered, right? But it has to be small enough, because once you establish that highway to delivery, and then people are using it and they'll inform you about the feedback around it, then there's nothing stopping you to optimize it at a much greater pace. So when you have something big, a huge project, there's a lot of complexity. It's very scary. And then you also have to have this command and conquer type of like management role where you tell people what to do. But if you bring it down to bar 1 first, something that you can do and something that you can prove certain kind of results to get potential feedback or whether you're in the right direction, that should be the first thing that you should be doing.
sharing your personal experience. Manbir, do you have any personal experience that you might have struggled that it's okay for you to share?
Yeah, I think when I started my career as an external IT auditor, right? So there are multiple occasions where you have to interact for walkthrough sessions with the control owners or process owners. So they, you see, you must understand that they have years of experience in the process, right? So when they're actually giving you the understanding, you might need to stop them at certain sections. You have to ask, I'm sorry to stop you, but I would like to understand, what do you mean by this, right? What do you mean by this word? Because sometimes your interpretation of this phrase might be different from their interpretation. So it's very important, you as an auditor, because you need to control the narrative of the walkthrough so that you get the required information by asking the right questions. So I think that's very crucial. So that is something which I challenge, because that was one of the challenge for me in the beginning. Then slowly with the experience and gradually it took some time to build a thought process in controlling the narrative for the walkthrough.
Okay, next question. Can any of the speakers expand on the role of deep learning and how it may disrupt, improve day-to-day functions of a society? That's a very broad question.
Yeah, sure, Tian, go for it.
Okay, I'll have a stab at it. Deep learning is not my expertise, but it starts from a foundation of neural networks, which is inspired from biology or the human brain. Actually, a lot of the technologies take a lot of inspiration from biology, such as ant colonies and things like that, as a starting point to invent things over here. I will not pretend to explain the full details of it in 2 minutes. I will leave that as a homework assignment for you to do your own research, compare with a few sources, and pick the most, define it for yourself, most importantly, what deep learning is, right? Essentially, it's neural networks, but that's just another word. What is neural networks? You need to demonstrate your understanding and try to explain it, all right? So that's the challenge.
Yeah, if I can just do a 1-minute summary. So essentially, deep learning is just one specific tool in the data science toolkit, right? So for example, it's just, you'll hear of other models like random forest or decision trees or gradient boosted trees, or things like, what are the others that I can think of now? Support vector machines and so on. They all just do the same thing. Neural networks are just probably the flavor of the past few years, because the strength of these neural networks and these deep learning models that we found is that they have a very good capacity to learn from huge amounts of data. And now the data regime that we're in is the petabyte scale regime, right? And so these models have the capacity to learn information from even gigabytes upon gigabytes of data per hour. And that's something that was lacking in previous models. And that's why deep learning is so popular now.
Okay, next question. To any of the speakers, from experiences, does everything you learn in university useful when working in the workforce? Manbir, would you like to answer that question?
Yeah, I would like to answer that. Actually, yes. I mean, definitely looking at the learning curve, right, of the industry, especially how fast and how evolved technology is becoming, right, you definitely can apply what you've learned back in college. For example, one key fundamental which I've learned at college, which I'm also still applying right now, is like, because at college I was required to develop this this application. It was a web application system. So you have the front end with the user interface and the back end, the database, right? So using that simple skeleton, right, I'm able to apply and expand more ways of testing it when I'm doing my current audit. Obviously, you learn the fundamentals, you learn the basic and the foundational knowledge, and then later on you have to do your own research and so on. So definitely what I have learned, I think, yes, there's a high level of relevance to it. It's just that how are you going to apply whatever you've learned back then?
I'll just add a bit over there as well. It's necessary, it's not sufficient. We have to learn a lot of things along the way. I will caution you to not discredit that what you're learning is not useful, because it can find a way for you to apply in future. So you do your best to understand what you're learning, even if it can be dry. All right. If you're an auditor, you need to do a lot of reading. That's just part of it. All right. Even if it does not benefit you in terms of the content knowledge, it benefits you in terms of the process of how you actually take all that information and do something with it. Now, having said that, there's a scope in universities, and each university has a different scope. I would challenge you to look at other sources as well, right? Use some other external materials to augment your learning along the way. And that will be what you can do within your own control to thrive in this ever-growing field.
Angertdev, do you have anything to add?
No, I was just going to add the necessary but not sufficient, but Tian already did, so perfect.
Great minds think alike.
Okay, next question. Are there any short courses to learn some basic data science to get into the industry and apply for jobs? I think this question.
Yeah, sure. So there's plenty. There's no shortage now, right? So some of the popular ones, you will see Andrew Ng's that are recommended quite often. There's also Fast AI, which is recommended quite often, and I think that was quite good for people who want to learn in a more like you want to see the results first, and then you want to learn the deeper things later. If you like to learn that way, then that's good as well. Andrew Ng's is good for foundation, so understanding, because you build these tools from the ground up. So you get a deeper knowledge, but don't limit yourself just to these two, right? There's a lot of other sources that you can learn from, and really the best way to learn these things is just by doing. Because when you're learning these things, they hold your hand the entire way through, and it's good for you to basically gain the knowledge, but there will be a lot of assumptions that you make that you won't realize until you try and use the tools. So think of a project, think of a problem you want to try and solve, and then go out there and try and collect the data to solve that problem. Go out there and try and train a model to predict whatever thing that you want based on the data that you collected, right? And along the way, you will find 100 problems, and then go on Stack Overflow and find solutions to 100 problems. That's the best way to do it.
Also, somebody asked, are there any links to these courses?
So I'll take that one. Just Google the links. If you want a premium, most basic one, even Google themselves have a machine learning glossary for you to have a good feel of the field, right? And their courses trend out every single time, right? And it's not for us to say what links are the best. You can tell just from the ratings alone whether or not these are the ones that you should try, and whether it's good for you, you will only know from doing it.
All right, nicely put. Okay, as a data scientist, what is your view on Apple shutting down data mining and giving power to the user from invasive tech companies like FB? Should I repeat the question? Or
sure. Is this a question for Manbir or?
If you guys want to answer it, you guys are most welcome to.
Sure, I think
Okay,
I'll just give my
repeat
quick
the
2 cents
question
for this one. Basically, I think
Okay.
it's good that people have more autonomy over their data. And, I guess one thing is that we shouldn't be, hope that corporations, out of the goodness of their hearts, do these things. And, the more that people are aware of the way that their data can be used, hopefully people will start to advocate for policy-based ways of securing their data. And, I think there's a lot more that needs to be done from their point of view. So I guess what Apple did is good from a consumer point of view, but we shouldn't be just hoping for corporations to do this by themselves.
Sorry, I didn't get the question. Could you repeat again?
The question was, as a data scientist, what is your view on Apple shutting down data mining and giving power to the user from invasive tech companies like FB?
Angertdev has already answered it. Yeah.
Okay. Next question. What are the salaries like a data scientist or a cyber or an IT auditor, like the starting and the average salary?
Okay, so I think as a fresh graduate, right, it depends on the size of the organization and also their budget. right? But generally, as a fresh graduate, I think the starting salary will be about 3,000 ringgit and so on. And it depends on the career pathway which has been established by the organization. So usually, if let's say every 2 years you are able to perform, you are able to meet your KPI and go above and beyond a KPI, I think then the organization is willing to promote you, maybe from an associate to a senior associate and so on. So depending, so generally the increment is about 10%, but if let's say right now, if you want to jump from company A to company B, so that's where actually you get a bigger jump in salary. So the standard increment is maybe usually about 30% of increment. But so I think this is my personal advice, right, to fresh graduates or even students. I think at this point, salary, monetary value shouldn't be a main concern. During your first few years, the foundational years, right, it's about how can you gather the necessary skills, build your learning curve, so that later on, 5 years or 10 years down the road, you know what's your market value, and that's where you can really demand when you are a subject matter expert. So during the initial years, don't worry a lot. It's more about joining the right organization, being mentored well, and building that foundation so that one day you would know that this is the level of salary which I can demand. So this is my personal advice.
Is the salary different for data scientists or about the same as what Manbir
Well, I
said?
think in general, I'm going to give a non-answer here because it's actually quite fluid. Depending on what you are capable of, depending on the industry that you're working at, heck, even the geographic differences, right? If I'm paid minimum wage from a London company, which I did before on my internship, that's actually sufficient for me to live quite comfortably back at home. So I'm going to give a non-answer, but what I will tell you is that you want to be able to ask a few more people because you just be getting a data point from one person that's pretty biased towards what my experience is like. And don't be shy to negotiate.
Yeah.
Right?
But so I just would like to add on. So negotiation is another topic on its own. So it really depends. So some organization, when you want to negotiate on a salary, they would tell, they're just willing to accept. But some organizations, you have to justify why are you demanding this level of salary. But I think this so it depends individual to individual.
You really have to sell yourself if you want that higher salary. Okay. Okay, this is the last question. Okay, I think this is to all the speakers before we leave. So what are some words of wisdom or advice that you would give to fresh grad that are starting up in this field? I think we can just go around in a circle and maybe just give some advice to those fresh graduates. So, Manbir, you want to start since you're
let me capture the essence of the question. So, words of wisdom, if let's say you want to commence your career in cybersecurity?
Yeah, so like words of wisdom or advice that you would give them or maybe yourself when you were starting to venture into that field.
Okay, so my advice would be, number one, I think if let's say you want to venture in the field of cybersecurity, having basic ethical hacking skills would be very crucial. So you just can go to YouTube and learn how can you do a vulnerability assessment, penetration testing, and so on. Learn what are the available tools and learn how can you actually utilize these tools to do the necessary exploitation. So basic foundational ethical skills are very crucial. And then slowly moving on, you should decide on what's your career direction, because cybersecurity itself is a huge umbrella. Within this umbrella, you can actually specialize into IT governance, IT risk, IT auditing, being a SOC analyst, right? So many different divisions, right? So so you already have a career direction, good, stick to it, build your knowledge, and slowly once you realize that this is going to be my area of specialization, then take a deep dive into it. Because at the end of the day, if you want to stand out, or if you want to have a unique value, it really depends on how specialized is your skills and your knowledge.
I will add to that. If you're starting out, and this is because you haven't even started learning some of the fundamentals of the basics of this, start with where you are. You can YouTube a lot of these things. You can Google a lot of these things. Pick a very simple project and do it for yourself and gain understanding gradually. It's one of those things that is easy to start, difficult to master, right? So there's a lot that come with this. I think one of the key traits that I had in being able to learn so much is you have to teach this unconditionally to other people, even if they are, students within your own classroom, because they're not in competition with each other. They can ask you questions that will stump you, and then you are now forced to think of an answer for that question, and it might be a very well-defined question. So I have never lost anything when I teach others unconditionally. So that's what I would say.
When you teach people, you get a better understanding of that topic. Okay,
Yeah, sure. Yeah, I think along a similar theme, I think the other thing that's really important is if you've identified that this is something you want to learn, the good news is that for data science, there are so many communities that want to learn these things together. So for example, in Malaysia, now with COVID, I think they've probably moved online, but there were meetup groups where one or two people in that community will give a certain talk on something, and then everyone will, we'll have a practical demonstration where everyone will join in. And finally, at the end, everyone will mingle, so you get to know people within the industry better, and also other people who enjoy similar things. But you don't have to limit yourself just by geography now, right? So there'll be lots of Discord channels as well that are related, where people come on to learn these things. There are also subreddits that you can join, that people discuss data science on. And when you have a community that's always talking about these things, it's a lot easier to stay interested. And if you stay interested, then it doesn't feel like a chore anymore, learning. And that's something that I highly recommend that you do as you're starting out.
So I just want to add on a quickly, because just now I told that it's very important to build the foundational understanding ethical hacking, right? It's very important when you have the knowledge of ethical hacking, do not try it on public websites like Maybank to website or CMB Clip. This is very crucial. I've learned this the tough way. So if you're going to do ethical hacking, make sure you have the permission of the website owner. So this is something which I really would like to advise. Yeah, thank you. So don't take my words literally. Make sure you do your proper due diligence process on it and get the necessary approval. If not, you can be behind the bars lah. Yeah.
Yeah, guys, keep that in mind before doing anything. Okay, so unfortunately, it looks like we have come to the end of today's talk. I would like to thank all the speakers for being with us here today and spending a little bit of their time, as well as sharing their knowledge with us today. So thank you so much, and I hope everyone have a great day ahead.